Welcome to section 3.4, Radian measures of angles. After this video, you should be able to answer these questions. What is a radian? What does it mean to subtend an arc? How do we calculate radian measures given degrees? And how do we work with radian measures on our calculators? How do we convert from radians to degrees and vice versa, manually and on our calculators? Which angles should we memorize both their degree and radian measures? All right, well, let's start with the first question. What is a radian? Well, here's a surprise. A radian is a radius. Who would have seen that coming? But what does that mean? Well, here's a website that explains that a radian measure is just the arc length around the circle divided by the radius. A radian is a radius wrapped around the circumference of our circle. If I take one radius and I wrap it around, the angle that's created by wrapping that one radius around the circumference is known as 1 radian. If we want to figure out how many degrees are in a radian, we find out that it takes a little bit more than 3 radians to cover half a circle. In fact, it takes 3.14159, or pi, radians. So 180 degrees is the same as pi radians. So 1 radian would be 180 degrees divided by pi, or a little bit more than 57 degrees. The great thing about this radian measure is that it doesn't matter how large the circle is we're working with. If we wrap 1 radian around the circumference, it will always be the same angle, 57 degrees. So regardless of whether I have a 1 unit circle or an x unit radius for the circle, the same angle is subtended for the circle if we wrap 1 radian. To convert between radians and degrees, we take that proportion that it takes pi radians, or 180 degrees, to wrap halfway around the circle. They're equal to each other, so we can create this proportion. If we want to find the radian measure of the angle given degrees, we'd multiply the degree measure by pi over 180. If we want to find the degree measure of theta, if we start with radians, we multiply the radian measure by 180 degrees over pi. So that's what you need to know about radians from this section. And our final thought, there's a species of antelope that can jump higher than the average house. This is due to the antelope's powerful hind legs and the fact that the average house can't jump.